Hi, I'm Tim Gilbert. I'm your instructor for BUS320, and I wanted to talk to you about Chapter 3, Section 4, Measures of Relative Standing. We've been calculating mean and standard deviation in a previous section. Now let's see how we can put it to work to give us an idea of the probability of certain values showing up. Our z-score is going to help us with that, although it sounds a little intimidating right now. Calculation for it's relatively simple, and the z-score really gives us a relative standing or a value of when we pick a specific score above or below the average. Relatively speaking, how far away is it in standard deviations? So let's take a look at a calculation, and that'll help us. We've got our 6 values that we've used before. You've seen this little spreadsheet. I put in 6 values for systolic blood pressure, went up to stat, dropped down to summary statistics, had to calculate out an average and standard deviation and some other values. So we've got an average of 135, standard deviation of 11.489. I'll round it to 11.5. So we have a z formula that says if I have an individual value and I subtract the average, and then I'll push or divide the standard deviation into that difference, and that will tell me in standard deviation units how far away that point was from that specific average. So I've got z over here. I pick a point for it to represent x of 146.5 minus 135 over 11.5, which is standard deviation. That was the mean, 135. Came out to be 11.5 over 11.5 equal to 1. So relative to the standard, to the average, this value, 146, is 1 standard deviation away, because it's standard deviation divided in equal to a round number or to a whole number of 1. Now I've got another score. I've upped it some to 158. So I've got an x value there at 158, subtract 135, divided by 11.5. 23 divided by 11.5 equals 2. So relative to that average, that value of 158 divided evenly in there with standard deviation of 11.5 2 times. So this, relatively speaking, is 2 standard deviations away from the mean. There's a reason we're doing this. It's going to tie into some probability, so hang in there for another calculation. So now I've got a smaller value. It's below the mean. I've picked a value of 112, subtract 135, 11.25, negative 23, and now drops down to a negative 2 standard deviations away from the mean. Relatively speaking, that's 2 standard deviations away from the mean. Now the reason this has some application for us is there is a probability curve, a bell-shaped normal curve. It's in the back of your text inside the back cover. I'll just show it to you briefly here. Not that you'll be able to read it, but this is what it looks like. And if you look in there, there will be z-scores listed on the left-hand column, and you look down to a z-score of -2, and then or +2, and then move across the table and pick out a probability for that to happen. And that probability will determine for us if it's an usual or an unusual value. So imagine that normal curve over the top of this bar here, this horizontal bar, and right where the curve dips down, it's going to be up, single mound in the middle here, coming down right here at -2 and at +2. the probability of numbers happening diminish fairly rapidly into a low probability, where we would say if we had a value that was greater than 2 standard deviations away, greater than 158, it would be unusual to see that systolic blood pressure measurement that our medical students did for us to be higher than 158, and unusual that it would be lower than 112. Let's take a look at a Z normal curve calculator that I got off a website, and I'll send you the bookmark for that. We'll end our show here.